Hello student, this is Dr. GopiChand Negi, Assistant Professor, Department of Chemistry, presently working at GP Pant Memorial Government College, Rampur, Bushahar. Dear student, today I am going to discuss a very important topic in atomic structure, that is the discovery of subatomic particles. But before begin with the study of subatomic particle, let us briefly understand how the idea of atom developed through history. Dear students, the concept of atom is very ancient. The great Indian philosopher Maharshi Kanath proposed that all padarth means matter is made up of extremely tiny, small, indivisible particle called parmanu. According to him, these tiny particles combine in different ways to form various substances found in nature. Similarly, the great ancient Greek philosopher Democritus and Leucippus also suggested that all the matter is made up of very tiny indivisible particle called atom. The name atom itself derived from Greek word atomio, which means uncuttable or non-divisible. However, these ideas were mainly philosophical and were not supported by experimental evidences. The first atomic theory was proposed much later by the English scientist John Dalton in early 19th century. Although Dalton's atomic theory successfully explained many laws of chemical combination and laid the foundation of modern chemistry, but again basic idea of Dalton atomic theory is that matter is made up of tiny, indivisible, indestructible and ultimate particle called atom. But later experimental discovery shows that atoms are not indivisible. Scientists discovered that atoms themselves contain smaller particles known as subatomic particles. So dear student, in today's lecture we are going to discuss the discovery of these fundamental subatomic particles, electron, proton and neutron. Important experiments involved in the discovery of these subatomic particles, characteristic of these particles and the importance of these discoveries in chemistry. Dear student, let's begin with the discovery of first fundamental particle, electron, and the credit for the discovery of electron goes to English scientist J.J. Thomson, who discovered electron in year 1897 through discharge tube experiment. Dear student, here we need to understand that at the time of J.J. Thomson discharge tube experiment, people already knew about the electric charges, positive charges and negative charges, and they are also familiar with their basic behavior and interaction with in different fields. But they were not knowing that negative charges are generated because of electrons. To discover electron, scientists use a special apparatus called discharge tube. Discharge tube is glass tube fitted with two electrodes. This metal plate, which is connected with the negative terminal of the battery, is called cathode, whereas the metal plate, which is connected with the positive terminal of the battery, is called anode. And this glass tube contains gases, and it is also connected with vacuum pump to reduce the pressure inside the tube. The various observations of the discharge tube experiment were: at normal pressure, nothing was observed, but when the pressure inside the tube is reduced to 10 raised to power minus 2 atmospheric pressure, gas inside the tube become conducting and light is emitted. And when the pressure inside the tube was further reduced to about 10 raised to power minus 4 atmospheric pressure, the glow of the tube stopped, but gas, that is the residual gas present in the tube, continued to conduct electricity. When the anode metal plate was replaced by perforated anode plate, and this end of the tube was coated with some fluorescent material like zinc sulfide, it was observed that even at very low pressure of 10 raised to minus 4, this end still glow with faint greenish light, which helped the scientists to observe the path of these rays. Dear student, with all these observation, it was concluded that under ordinary pressure, electricity does not pass easily through gases, but at very low pressure and high voltage, strange rays are produced from the cathode. These rays were called cathode rays. After the discharge tube experiment, scientists performed several experiments to study the nature of the cathode rays. Let us discuss the important observation one by one. When the object was placed in the path of the cathode rays, a sharp shadow was formed on the opposite side. This shows that cathode rays travel in a straight line. When electric field is applied, cathode rays were attracted toward the positive plate. This indicates that cathode rays carry negative charges. Cathode rays were also deflected by magnetic field, which further confirmed that they consist of charged particles. Cathode rays can rotate a small paddle wheel placed in their path. This shows that ray consist of particles having mass and kinetic energy. When cathode rays strike certain substance like zinc sulfide, the substances glow. This phenomena is called fluorescence. The glowing of screen helps scientists observe the path of the ray as discussed already. Scientists use different gases, air, hydrogen, carbon dioxide, and different electrode material in discharge tube, but the property of cathode rays remain the same. Therefore, it was concluded that cathode rays are made up of identical particles present in all atoms. These particles were later called electron. Dear student, after discovering that electrode rays are negatively charged particles, J.J. Thomson performed another experiment to determine charge to mass ratio of these particles, represented by E/m ratio. In this experiment, cathode rays were passed through electric and magnetic field. The various observations that were observed was that when the cathode rays are made to pass through the electric and magnetic field, he observed under the influence of only electric field, these rays, cathode rays, deflected from their original path and deflected to strike on the fluorescent screen at point A mark, and similarly when only magnetic field is placed, he observed that these rays deviated from their original path and get deflected to strike on the fluorescent screen at point mark C. He observed that under the influence of both the electric and magnetic field of same magnitude, the cathode rays remain in their path. They were not deflecting and strike the fluorescent screen at point B. He observed these deflections depend on the magnitude of the negative charge on the particle. Greater the magnitude of the charge on the particle, more was the interaction with the field and more will be the deflection. The mass of the particle, the lighter the particle, more will be the deflection, and this point can be understood while taking one example, that if same force is applied on two objects of different masses, the lighter object will obviously cover more distance. Therefore, the lighter particles are getting more deflection. Deviation depend on the strength of electric and magnetic field. Greater the magnitude of these electric and magnetic field, more will be the interaction. Therefore, more will be the deflection. Therefore, by carefully balancing the electric and magnetic deflection, Thomson calculated the velocity of the particle and finally determined the value of charge to mass ratio particle of these rays. This value was extremely high, indicating that the particle of cathode rays have very small mass. From this experiment, Thomson concluded that cathode rays consist of tiny negatively charged particle, later named electron. This experiment was highly significant because it proved that atoms are divisible and contain smaller subatomic particles. Dear students, after J.J. Thomson determined the charge to mass ratio of the electron, the actual charge on the electron was measured by American scientist Robert A. Millikan in year 1909 using the oil drop method. In this experiment, a very fine droplet of oil was sprayed into a chamber containing two horizontal metal plates. A droplet coming through this hole into the compartment of two metal plates acquire negative charge due to friction or by exposure of X-ray. Initially, the oil drop fell downward under the influence of gravity, and when an electric field was applied between the plates, the negative charge droplet experienced upward electrostatic force. By carefully adjusting the electric force, Millikan was able to balance the force acting downward and the electric force acting upward so that a droplet remains in air. Using this balances of forces, Millikan calculated the charge present on a single electron. Dear student, he noticed that the value of negative charge is different on different oil drop, but he noticed that the charge on the different oil drop is always integral multiple of particular value, that is 1.6022 into 10 raised to power minus 19 coulomb. Therefore, he concluded that the smallest charge has to be smallest value, that is the 1.06022 into 10 raised to power minus 19 coulomb. And finally, it was concluded that the charge on the electron is this smallest value. And after the calculation of the charge on the electron and charge to mass ratio calculated by J.J. Thomson, the mass of the electron was calculated, which comes out to be 9.1094 into 10 raised to power minus 31 kg. This experiment proved that electric charge is quantized, meaning charges exist in discrete unit of this one. Therefore, this was concluded that cathode rays are stream of negatively charged particles present in all atoms. These particles are named electron, and the electron is defined as a subatomic particle which carry 1 unit negative charge 1.6022 into 10 raised to power minus 19 coulomb and has mass 9.1 into 10 raised to power minus 31 kilogram, equal to 1 over 1837 of that of hydrogen atom. Dear student, since an atom is electrically neutral, after the discovery of electron, it was realized that atom must also contain positive charge to maintain electrical neutrality of atom. The discovery of proton is mainly associated with E. Goldstein, who performed canal ray experiment. Goldstein modified discharge tube experiment by using perforated cathode having a hole in the metal plate. During the experiment, he observed ray moving in the opposite direction of the cathode rays. Rays are moving in this direction, whereas the rays was moving from anode toward cathode. These rays passes through the hole in cathode, therefore they are called canal rays, which is a Latin word. And since these rays are coming from the anode plate toward the cathode plate, they are also called anode rays. Dear student, in discharge tube, rays are stream of fast moving electrons. These are the cathode rays, and these are fast moving electron emitted from the cathode. When these electrons collide with gas, atom or molecule inside the tube, they remove one or more electron from them. As a result, positively charged ions are formed. These positively charged move toward the perforated cathode and pass through the holes, forming a beam called positive rays. The amount of positive charge on these ions depend on the number of electrons lost. Again, several experiments were performed to study the nature of anode rays. Let us discuss these important observations one by one. Like cathode rays, anode rays also travel in straight path. They are deflected toward the negative plate in the electric field, hence they carry positive charge. Similar to the cathode rays, they also rotate a wheel placed in the path, which shows that These rays are made up of particles having mass and kinetic energy. The charge to mass ratio depend on the nature of the gas taken in the tube. Rutherford observed that the hydrogen gas was used in the discharge tube. The positive particle obtained were the lightest particle carrying a single positive charge, and he concluded that these particles are fundamental constituent of atom, named them proton in 1919. Dear student, charge to mass ratio of these particles were determined by means of deflection in electric and magnetic field in the same way as did in case of anode rays, but the value of charge to mass ratio of these rays were found not constant and is considerably smaller than that of electron, and this can be easily understand by the fact that the mass of the proton is much higher than that of the electron. Therefore, the deviation these particles is very less. They are deflected to a less extent by the electric and magnetic field. The charge to mass ratio of anode rays was found to depend on nature of the gas taken, because the mass of the different gases is different. Therefore, their value would be also different. But in case of hydrogen, charge to mass ratio was maximum, and because the hydrogen gas is lighter one, that's why it has a maximum E to mass ratio, and found to be 9.58 into 10 raised to power minus 7 coulomb per kg, and charge has been found to be 1.6022 into 10 raised to power minus 19 coulomb, and has a mass 1.675 into 10 raised to power minus 27 kilogram, equal to that of hydrogen atom. Dear student, scientists observed that the atomic mass of many elements couldn't be explained only by electron and proton. Therefore, another neutral particle were suspected to be present in an atom in addition to electron and proton. Dear student, here we need to understand one thing, that if mass of the electron and proton are concerned, the mass of the electrons are negligible as compared to the proton, and proton itself is in the center of the nucleus, and if the electron and protons are the only subatomic particle that is present in an atom, that means the atomic number should be equal to the atomic mass, but in most of the cases the atomic mass is much higher than that of the atomic number. This, for example, in case of carbon, the atomic number is 6, whereas the atomic mass is just double of the atomic number. This extra mass couldn't be explained by proton alone, suggesting the presence of another particle in the nucleus. The neutron was discovered by James Chadwick in 1930. He set up an experiment. Chadwick bombarded beryllium with alpha particles. As a result, highly penetrating neutral radiation was produced. As these radiation were not affected by electric and magnetic field, when these radiation struck paraffin wax, protons were ejected at high speed. This is due to the fact that the neutron itself has a mass equal to that of the proton, hence it ejects the proton from the paraffin wax. From this observation, Chadwick concluded that the radiation consists of neutral particles having mass nearly equal to that of proton. These particles were named neutron. So we concluded that the radiation consists of neutral particles. These particles has a mass nearly equal to that of proton, and Chadwick named them neutron. Thus, a neutron is a subatomic particle having mass 1.67 into 10 raised to power minus 27 kilogram, equal to that of the hydrogen atom, and carry no electrical charge. So, dear students, the discovery of subatomic particles completely changed the concept of atomic structure. It helps scientists to understand the internal structure of atom, explain electrical conductivity, develop modern atomic model, understand chemical bonding, explain radioactivity and nuclear reactions. Thus, atoms are made up of three subatomic particles, electron, proton and neutron. Understanding these particles is essential for studying atomic structure, chemical bonding, spectroscopy and modern chemistry. So this is all about for today's lecture. Thank you very much. In the next lecture, we shall study the atomic models and evolution of atomic theory. So till then, thank you very much.